Hey everyone, this video is going to be on how to do double replacement reactions, or sometimes called double displacement reactions. So the first thing that you need to remember with double displacement is that you're starting with two compounds which are both aqueous, and you're making two new compounds. One is aqueous, one is not. Now, to know that you actually fit this pattern, you have to look at a solubility chart. Okay, so there is a solubility chart in our textbook, but I did also release the solubility chart to you in your folder. Okay, so with double displacement, remember what we have is we have two compounds. They are swapping partners. So as I explained in the video, my positive charge, so the A is going to have a positive charge, it's going to bond with your negative charge. So the Y in compound BY would have the negative charge. So the compound on this side is AY instead of AX. Okay, and then this compound over here, the positive B, is going to bond with the negative X. So we have BX on the right-hand side. Which compound you have first does not matter, but remember, proper format, sorry about that, is to always have a positive charge before the negative charge. Okay, so let's try one. So we are looking at our worksheet. On our worksheet, we have aluminum iodide. So we have aluminum, which is Al, and iodine, which is I. Aluminum has a positive 3 charge. Iodine has a -1 charge. So therefore, swap and drop. Okay, so aluminum takes the 1, iodine takes the 3, plus... Actually, let me give a little room there so we have room to say what state it's in. We are combining with mercury 2 chloride. So mercury is Hg. They have a positive 2 charge. Chlorine is -1. Swap and drop. So chlorine takes the 2. Mercury gets the 1. Okay, draw our arrow. And actually, I always suggest to my students for the beginning part to keep the charges so that you don't get confused. So my positive 3, is going to bond with your negative. Cl is a -1. So aluminum, which is positive 3, is now going to bond with chlorine, which has a -1. Swap and drop. AlCl3. Plus... mercury, its positive charge, is now going to bond with iodine. So mercury, which is positive 2, is going to bond with iodine, which is -1. So we have the positive 2, swap and drop, -1, swap and drop. Okay. Now, what we need to do now that we put our compounds together is we can go ahead and balance our equation. So we have aluminum, 1 on the left, 1 on the right. We have iodine. Iodine has 3 on the left, 2 on the right. We have mercury, 1 on the left, 1 on the right. We have chlorine. We have 2 on the left, we have 3 on the right. So iodine and chlorine are the two that are not in a good spot. With both of them, you're looking at the relationship of 3 to 2. So we're going to go ahead and do least common multiple. So the least common multiple for iodine between 3 and 2 is 6. So if I want 6 iodine on the left, I'm going to multiply this by 2. That now gives me 2 aluminums. 2 times my 3 iodine gives me 6 iodine. You could have started with the iodine. You could have started with the chlorine. Doesn't matter. Okay, if I want 6 iodines on the right-hand side, I have to multiply iodine by 3, because 3 times my 2 iodine give me 6 iodine. 3 times my 1 mercury gives me 3 mercuries. Okay, now we have to go through and balance. Our aluminums are not balanced, our mercuries are not balanced, our chlorines are not balanced. It does not matter if you start with the aluminum, the mercury, or the chlorine. Okay, I'm going to go ahead and start with the chlorine because that's one that wasn't balanced from the beginning. So again, chlorine is a 2 here and it's a 3 on the right. So we're going to use least common multiple for that. So the least common multiple between 2 and 3 again is 6. So if I want 6 chlorine on this side, I'm going to multiply mercury chloride by 3. That gives me 3 times my 1 mercury gives me 3 mercury. 3 times my 2 chlorine gives me 6 chlorine. Over here on the right-hand side, if I want 6 chlorine on the right, if I want 6 chlorine on the right, I'm going to multiply this whole entire equation by 2. 2 times my 1 aluminum gives me my 2. 2 times my 3 chlorine gives me 6 chlorine. Okay, now we have to go through and check to see if things are aqueous or not. Do we fit the pattern? So we have silver iodine, mercury chloride, aluminum chloride, and mercury iodide. So we're going to go to our solubility chart. And most of the time, you're going to find things by the second compound. Second element in the compound. So we're looking for iodine. Iodine and chlorine are both halides. They're both in the halogen family. So we are looking right here. Halides, halogens, are typically soluble. Okay, soluble means aqueous. Unless they are bonded with silver, mercury, or lead. So I come over here to my equation. My first one is aluminum iodide. Aluminum is not an exception to the rule, so therefore aluminum iodide is soluble. Remember, soluble means aqueous. So I'm going to give an AQ here for aqueous. My next one is mercury chloride. Okay, so I have my halogens. They're all soluble unless, okay, look at this. Mercury with a positive 2 charge is what we're actually bonded with right now. So therefore, this, instead of being soluble, is going to be a solid. So mercury chloride is going to get the S for solid after it. Aluminum chloride. So I come back up here to my solubility chart. We still have a halogen. They are always soluble unless aluminum is not an exception to the rule. So we're going to come down here to our paper and put an AQ next to aluminum chloride. Mercury iodide, again, mercury is an exception to the rule. So instead of being aqueous, it's going to be a solid. We look at our format. We have aqueous plus solid. Okay, equals aqueous plus solid. That does not match. We're supposed to be aqueous plus aqueous equals aqueous plus solid. We do not match because we start with aqueous and a solid. So what we're going to do is put a big X over top of the arrow. All right. Hope that helped everybody. Talk to you later.